Okay, let's continue here. So I hope you found your GCF. There is, I see 2x on the numerator. So if we factor out 2x here, that would be 3x squared minus 5x minus 2 all over. Let's look at our denominator. I see 2. Okay, so 2 is common, so that would be 27 x to the third plus 1. Okay, let's see if we can still factor or factor further. You can also put a 2 there. Do not start canceling right away. Okay, factor everything first. So this one is, let's try bottom up here. And let's try here. 27 is a perfect cube, 1 is a perfect cube, so that is a sum of cubes. Okay, so do it on the side. Okay, factor that as bottoms up and this one as sum of cubes. Okay, so 2x, if you factor that, that would give you 3x plus 1 x minus 2. Okay, and then this one here 2, and then how do you factor a cube? 3x plus 1, then you square the first, 9x squared, you square the second, then you multiply the 2. Okay, so these are your factors, and you know you cannot multiply that anymore. In polynomial graphing, we multiply because we could have I, we could have other factors, but now it's all real numbers only. So let's try to cancel. Okay, let's try to get our constraints first. So this one will never be 0. This one is x is negative 1/3. And here, if you try this, make it equal to 0. Or you can write it as 9x squared plus 3x plus 1. Then you could try quadratic formula here. And you will see that you're going to get an I. So that will never be 0. Okay, so on the side, if you'd like to do that, 9x squared plus 3x plus 1 equals 0. And then use quadratic formula. You will see that you will have an imaginary number, which means that this will never be 0. Okay, so our only constraints is negative 1/3. So let's simplify this. Let's cancel 2 and 2. 3x plus 1 cancels with 3x plus 1. So what's left on the numerator is x times x minus 2. And in denominator, we have 9x squared plus, let's just write this first, so it would be in standard form. Okay, and again, our constraints, if x is not equal to negative 1/3. So that is how you simplify. So try to practice these three. Simplify. Okay, simplify rational expressions. That is our first lesson, how to simplify. Okay, next, on the next lesson, we're going to multiply, divide, and add and subtract. Okay, so for today's lesson, we just simplified, and now we're going to graph. Okay, so rational expressions. Okay, rational functions. The parent graph of rational function is the simplified form, or the simplest form of rational function is y equals 1 over x. This is our parent graph. We already have so many parent graph. Okay, so can you make an x and y table for this? Give as many values as you can and try to graph this. Okay, the graph of the parent graph of rational functions y equals 1 over x. Graph. Make a table and graph.